Okay, so these are notes on Chapter 9. This first video only covers Section 9.1. And the first thing we're going to do, we're going to, of course, library all of our packages that we need. Tidyverse, always. SF, almost always. Terra, from now on, almost always. And Tigris, we need to get some geographical data, boundary files. And then Prism, which is going to get us weather data. Okay. And first thing we're going to get is the county boundaries. And this county's function is in the Tigris package. I set progress bar to false. This was not in the code in the textbook. Progress bar false stops you from seeing a horrible amount of output. You'd have to scroll down a couple times to get past it all. And when we look at what we got out of that call, it is an SF object and it is a data frame. And in order to see things a little bit more clearly, I have to take this full screen. And you can see the data items. The first one, the state FIPS code, is 5. The county FIPS code is 121, which gives us a GeoID of 05121. And we're looking at Randolph County in Arkansas. And you get the land area, the water area. Okay, I'm not really all that interested in all that. So for what we're going to do in the future, we need to have state FP and GeoID as numeric variables. And instead of overriding them, we'll create new variables. State will just be the numeric version of the state FIPS code, and FIPS will be the numeric version of the GeoID. And then, importantly, to make this thing visible on a screen, we have to eliminate Alaska, Hawaii, and all of the island possessions. State less than 60 gets rid of everything above 50, really. I'm sorry, yeah. It leaves you with anything below 50 or below. Okay, and I wanted to look at the coordinate reference system for that thing. And this is the look at coordinate reference system from the textbook. And this is it, and you see the important thing really is EPSG 4269. And remember that number, because we're going to have to worry about, always have to worry about coordinate reference systems being the same for every object that you try to put into a single graph. And you didn't really need all that fancy stuff. You could just see ST underscore CRS of county, and you get the same information. It isn't organized quite so well. But again, the most important thing is the EPSG code. Now we start with Prism. Prism has to have a specific place to put its data, and I define the Prism path with this option statement to be dot, which just means the current working directory. And then I'm going to get the 30-year normals for annual precipitation from Prism. So type is PPT, that is precipitation. Resolution is 4 kilometers. We can do better, but for a national graph, we would prefer to have 4 kilometers. Annual is true, and keep zip is true. I didn't need to do that. I keep the zip files, but I can't think of anything I really use them for. And we're also going to get the Prism data for all the months in 2018. So we specify the years is just 1 year, 2018. Month is 1 through 12. And again, you get a bunch of junk. I'm going to download 12 different data sets. Okay. So the monthly data is not specified. Only 4 kilometers is available on a monthly basis. So now we have to organize the access to the data that we just downloaded from Prism. And I'm going to create prism_files as prism_archive under ls. You remember, you recognize a directory request. And then look at prism_files. You can see that what it is, you can see that items 1 through 13 are just character strings. And if I look at the structure of prism_files, it just says it's a character vector with 13 variables. Okay, now I have to define the paths to the Prism data. And to create prism_paths, I run file.path, and it says start with the current working directory, then /prism_files, then / the paste to 0 of prism_files and the character string .bil. The BIL file is what you're really going after. That is the image. It's kind of like the equivalent of the TIFF file in other things. Okay? So prism_paths, again, is just a vector of character strings. And if you look at the first item, you see that it points to the BIL file. You actually got the same thing here when you looked at the structure. Okay. The next step, in order to use the Prism data, you have to convert it to a raster, or, well, a bunch of rasters. So here's where you apply the rast function to prism_paths brackets 1, which will be the first file that we downloaded, the 30-year normals. And then we get all the 2018 data. This is prism_paths items 2 through 13. And if you look at what they are, it is a SPAT raster, 621 rows, 1,405 columns, 1 layer. And it gives you the extent. So something about the coordinate reference system is long lat 1983, NAD 83. And here we have the P30, the 2018 data. And note that this is a stack, actually, of rasters. Same rows, same columns, but this one has 12 layers, one for each month of the year. Okay, so that is it for section 9.1 of chapter 9.